right, what's our common factor that we can pull out of this?
X.
And I think I heard it quietly, and yeah, and a 2. Because we've got to even, oh, no, we can't pull out.
It's 1.
Yeah, no, I thought we could, but we can't. You're right, just an x. So this is going to give us a 6x squared plus 7x plus 2. Okay. Now, what I'm looking at right now is something where what's true about this number, it is not 1. So this is going to be the harder factoring problem. On the previous slide, you had a 1x squared, so you just did the AM. Here, we have a 6. So do you remember how to do the telephone method? Remember this? So I draw my telephone. Isn't there a song about telephone by Rihanna? Right? Isn't there? Like, telephone. Okay, never mind. Like, anyone know what I'm talking about? Maybe it's about a payphone? No, that's Maroon 5. Okay, anyway. 6 times 2 is 12. Remember how we do 6 times 2 is 12? And then I'm trying to add to 7. What two numbers multiply to 12 but add to 7? 4 and 3. 4 plus 3 is 7. 4 times 3 is 12. All right, so as a reminder, we need to split up the middle. And this is nothing new. If you need to go back and watch the factoring videos, you can. So I'm going to take this and I'm going to split it up. Now, sometimes it matters. Should I put 4 then 3 or 3 then 4? Yeah, it has to be 3 then 4 because the 3 has a factor with 6 and the 4 has a factor with 2. If we switch that, the 4, 3, the 4 has a factor with 6, but the 3 will not have a factor with 2. So this is going to be written as a 6x squared plus a 3x plus a 4x plus a 2. Drop down your x. Just going to write it like that. And if you want, you can ignore the x till the end, but just remember to put it back in. Okay, so now I go underline, underline. What can I pull out from a 6x squared and a 3x?
3x.
Yep. Which is going to give me a 2x plus 1. And then I immediately write it again. 2x plus 1. What does this number have to be so that I get a 4x plus 2?
2.
Yep, 2. Now, if you want to be really good at math and like really meticulous, you would drop down the x and you still have that. So again, I'm going to drop down that x, which has had really made no difference yet. And I've got a 3x plus 2. And what's my other binomial? 2x plus 1. So if you're confused about where I got these from, that x just came from dropping it down the entire time. Okay, oh, I had a pink marker somewhere. Here it is. The 3x plus 2 came from that. And the 2x plus 1 was written twice, but we only read it once. And that's because we're pulling it out as a factor. So we're done with half of this problem. we have rewritten this thing right here as a factored form. And now I need to solve it. I need to find the three numbers, or maybe two, or maybe one, that make this equal to 0. One of them is easy. It's the one on the outside. What would this have to be to make my whole thing 0?
0.
Correct. Now, this is much harder. We want this to be 0. I cannot do it in my head. So what I do is I actually set up an equation, 3x plus 2 equals 0, and I solve it. So to solve this equation, this is back to algebra 1. I subtract 2 from both sides, drop down to 3x, divide by 3, x equals minus 2 thirds. And that's what, negative 0.66666. So that's my second answer. And if you're like, how'd you get that? Well, I got my x equals 0 answer from this. Then I took this, set it equal to 0, and that's why I got this answer. Now what's the last thing I'm going to set equal to 0?
2x plus 1.
Yep, 2x plus 1 minus 1. 2x equals negative 1 divided by 2. X equals negative 1/2. We're done. You're like, thank God. And you have 3 answers. So sometimes these problems are fairly easy because you can do the easier factoring method. And sometimes they're really easy because you can just do these things in your head. But this was a particularly hard problem because it's a hard factoring problem and we had to take time to set these equal to 0. All right, go ahead and open up your page to 10 and we'll do a couple together.